Hi, Sophia. I am going to send you this document as well so that you can look at it, but here's a quick video to hopefully help you with the parabolas. This is showing a picture of what the parabolas look like. So they're the same U shape as before, but they also have a focus point and a directrix line. So the vertex is the same, and the focus is always a point, and it's always inside of the parabola. So if the parabola opens a different way, your focus will be moved. Your directrix is always a line, and you'll see on my graphs that I do it as a dotted line that is outside of the parabola. So here is what the x squared parabolas look like. X squared means that it's going to open either up or down, and it depends on the sign of this number right here. If it's positive, it's going to open up, and if it's negative, it's going to open down. I'll show you an example of that in just a second. And then here's what the y squared parabolas look like. They're always going to be opening sideways. And so again, if it's positive, so this shows right here, if it's positive, it's going to open to the right, and if it's negative, it's going to open to the left. Notice again, like I said on the first slide, that your focus is always inside. So here it's to the right of the vertex, but here it's to the left. Your directrix is always on the outside of the parabola. So in the equation, you will see a number. This part right here will be a number, and that number is equal to 4p, so that's like a formula. The p part is the distance between the vertex and the focus, and the vertex and the directrix. So it's going to be the same distance away on either side of the vertex. So here's an example. The first thing that you had to do on this one is make sure that the squared part is completely by itself. I'm not sure if you'll have to do those on your examples or not, but if your equation starts like this at the top, you have to make sure that that y squared is by itself. If it starts like this, then you don't have to worry about that step. This number right here now is the 4p that I showed you on the last slide. So we do this little side work right here, 4p equals -4. We solve for p and we get -1. That means that your focus and your directrix are 1 unit away from the vertex. And we know that they're going to be down and up here in this situation because at the very beginning we noticed it was x squared and a negative. So since it's x squared and the p number is negative, then it will open down. So I put my vertex. This one is at 0, 0. I'll show you one in just a second that's moved. And then your focus has to be inside. So we go down 1 unit and put your focus. We go up 1 unit and your directrix. Your directrix is always a line. And then I'm going to write those over here. The focus is an ordered pair. The directrix is an equation. The axis of symmetry, AOS stands for axis of symmetry. I'm not sure that your questions will ask you for that, so you may not need to do that, which is fine. That's just showing the symmetry between the parabola over here when we draw it. To get your other points on the parabola, I have this written on each graph slide. So to get your other points, you have to do double p. So in this case, p is equal to 1, double p is 2, and I go 2 units on either side of the focus. So 2 units to the left, 2 units to the right, and I connect those with my vertex. So here's another example that has been shifted. So your vertex is no longer at 0, 0. If you notice that we have some extra numbers in here, that is going to give you your vertex originally. They're always liars. They're always opposite signs. So -1, +2 is your vertex. I also notice right away that it's an x squared still, the side with the x is squared. And this number, the 4p, is positive. So because it's x squared and it's positive, it's going to open up. And I can figure out my p-value here. Remember the formula 4p equals 8. So p is equal to 2. That means that your p tells you the distance to your focus and your directrix. So I know it's opening up. I put my vertex on here, and then I know my focus is 2 units above because it's inside, and my directrix is 2 units below because it's outside. Then remember to find my other points on the parabola. I have this written down here again. You have to go double p. So in this case, your p is 2. Double p would be 4. So I go back up here, and from the focus point, I go 4 units to the right and 4 units to the left, and then I'm going to connect those with my vertex to make my U shape. So hopefully that helps a little bit with the placement of the focus and the directrix. I did notice on your quiz the couple of questions that you missed look like this. And so the difference from this equation and the ones that I was showing you here, This graph you can look at, but this graph is a y-squared. That's the only thing that's different. So if you have questions about that, let me know. But the y-squared just means it's opening sideways. The questions on your quiz look like this. So your equation looks a little bit different. We have to make this equation look like the other equations that I've given you as examples here. So in order to do that, we have to complete the square. So we have to complete the square for x, which means that the plus 3 needs to go to the other side. I'm going to write y minus 3, and then I'm going to factor out the negative 1/4. We will deal with that later. And then I have to complete the square for this part right here. Sorry, I did this wrong. Let me try again. So if I factor out a negative 1/4 from here, I need this to say plus 4x, because if I were to distribute this back, that's going to give me my negative 1x. Okay, and so then if I'm completing the square here, I have to take the b term and divide it by 2. So that will give me 2. And then I square it and I get 4. So hopefully this looks familiar with completing the square. I think you've done that before in the past. If it doesn't, let me know and I can give you some more practice with that. But we have to complete the square here, okay? And so then this would be x plus 2 squared. This still has this over here. Now, I just added in an extra negative 1 over here. So that means I have to add in an extra negative 1 over here as well to basically balance out the equation again. I put this in here so that it would make it a perfect square here. And so I have to make sure that I put that on the other side as well to keep the balance. Otherwise I've changed the problem. Okay, so then now this is a different color. So y minus 4 equals, okay, let me backtrack again, sorry. The next, you can make that y minus 4. The next step that you'll have to do is move this, because remember on the very first slide I showed you that the squared part had to be by itself. And so we're going to multiply on both sides by negative 4 to get rid of that. And so you're going to have negative 4 y minus 4 equals x plus 2 squared. Okay, so we're almost done. The equation is done now, and so I have to look at, I'm going to think about the graph. I'm not going to graph the whole thing, but this question was asking me for, I think, the focus. What is the focus? I'm going to think about the pieces of the graph enough to be able to find my focus. So I see that it is an x squared and that it's a negative number over here for 4p. So that means that my parabola is going to open down. And my vertex is at negative 2, positive 4. So those are the liar numbers, the opposite numbers of what's in the parentheses up here. And so if I were to go and graph that, I would have something like this, negative 2, positive 4. And my other thing I can do is the 4p. 4p is equal to negative 4, so p is equal to negative 1. So because it's negative 1, that means it's opening down. And remember, your focus has to be inside, which means that my focus is going to be 1 unit inside of the parabola. So I'm just going to sketch a parabola here because I don't actually have to find all my points. I just know that it's opening down. So my focus point would be negative 2, positive 3. So it's 1 unit inside of the parabola. If this question were asking for the directrix, you would have to do everything the exact same, and then your directrix would be y equals 5, because it would be 1 unit outside of the parabola. So I think that's what the other questions were asking you to do. The big thing here is that you're making this equation that they give you at the very top look like these equations that I gave you as an example. So you have to have a perfect square part in there. You have to have a part that says parentheses squared. That way you can find your focus and your directrix. So if this part right here does not look familiar, this part right here does not look familiar, go refresh on completing the square. So quadratic equations completing the square, and that will help you with this piece. And then once you get it into the equation, the correct equation, I hope that it makes a little bit more sense now with the focus and the directrix of how to find those pieces. I will tell you that this is something we do in Algebra 2 here at the high school level. We don't do it in geometry at all. And so if you can get enough grasp to try the questions on the quiz again, try the questions on the test. If I need to give you some points back, I don't mind doing that. This is definitely something that is way more advanced than regular geometry. And so I think it's good for you to learn because, again, you'll do it again in Algebra 2 and beyond, and then you'll know how to do it when you get there, but it's not something that we have to be mastered at this point. So if you have other questions, let me know. I don't mind making another video, or we can email back and forth, and hopefully that will help you. Okay, have a good day.